Hello everybody, welcome back to your channel Eco Engineering. In this video we are going to talk about the inheritance topic in object-oriented programming in Python. In 2 videos ago we discussed about how to implement classes and how we define objects in Python, what are attributes and methods in objects in Python, and how we can work and define them. The previous video, which I leave you the link here at the top of this video, is actually somehow a prerequisite for this video. I highly recommend you, if you are not familiar with object-oriented programming in Python, go and watch that video so you will learn it. But here you can still somehow review it and we go forward together. So now we are in the extension Jupyter of Microsoft Visual Studio. It's completely the same with the Jupyter. I just prefer it. The Jupyter Notebook, I just prefer to work with this one. So the first thing that we do, we are going to define some classes for the employees of a company, and then we just want to extend them to the different departments, like for example managing departments, engineering departments, like that. Okay, we just define a class, and this class is called employee and initialize file, like that. So here for this initialized file, we have input name and then age and then, for example, in trans year. So we can delete this section too, or you can keep it. It doesn't matter. Here in this initialization section, we say self dot name, and it is equal to name. This name is the name that will be entered by the user, and then we save it in this variable, self.employee name. Both of them together are one variable, and it is called self.employee name. But normally, I wrote it because I wanted to be more clear, but normally we don't use this self.name, and we just say self.name equal to name. But remember, this name is entered by the user. Self.name altogether will be considered as a variable. And in this class, we, instead of using this name, we always use the name itself. Okay, so then we say self.age is equal to age, and self.entrance year is equal to entrance year. And then we define another method, and it is called experience method. The first input for this method is self, because we want to have access to these attributes that we define in the initialization method here. And then we want another input. It's called current year. Normally we just use date and time object to have access to this current year, but now we just, because of simplicity, I just enter it manually. Okay, and this method returns current year minus entrance minus self dot entrance year. So it just returns the subtractions of the current year with the year that the employee starts working in the company. So if the employee has started at 2018 and now it's 2024, then this employee has been working for this company for almost 6 years. So I press shift and enter and I run it, and I define employee 1. It's equal to this employee class, and when I press parentheses, I can define the inputs for this initialization method. So the first one is name. The name is, for example, here Tim, and then the second one would be age. The age is 25, and the year of entrance, for example, is 2021. This is for the employee 1. If I call employee 1 and press dot for it, I have a method. I can have access to the age attributes, and I can have access, for example, to the entrance year, or we have an experience method. If I add this experience method and enter the current year, for example, now it is 2024. If I press shift and enter, it returns us 3, because it just easily subtract current year, which is 2024, from 2021, and it returns us 3. Okay, now I define another class. This is the main concept here. I define another class, and this class is called managing department, and like that. Now, because even those who are working in a managing department, still they are employee of our company, I can use these attributes and this method that I defined here for the employees, like that, just like that. So for even the managers, I need the names, the age, and the entrance year, and I want to be able to calculate the years of experience and working that they have worked for the company. But if you have, for example, 10 different classes for each department, like managing department, engineering department, accounting departments, or services departments, it's not efficient to define this initialization method and this, for example, experience method for each of these classes. It's not efficient. And this is the core concepts behind the inheritance. Instead of defining them again and again and again, we just copy the employee class and paste it here for managing department. And now managing department class inherit all attributes and methods which are defined for this employee class. Okay, so after that, for now, I just say, for example, pass because I want to test it. I don't want it to do anything. But for example, for engineering manager, we have some employee and it is from, I add it to this class managing department. Still, it asks me to define the name, age, and entrance year. But although I have not defined it for this managing department, it's still inherited from employee class because I added employee class here. So the name, for example, is Peter, and the age is 45. The entrance year is, for example, 2015. I press Shift and Enter. Engineering manager. If I press that for it, I can still calculate the experience for it by entering the current year. I press Shift and Enter, and it returns as 9. We have not defined any experience method for this managing department, but it is still inheriting it from the employee class, which is defined here. So now instead of using this pass here, we define a method for it, and we call it team member num, and we should define self here, and we just want to return, for example, 10. Normally we should not return 10, and instead of returning a constant value, we should refer to the database and find out how many team member this manager has, and then we should return it. But now, because of simplicity, we just want to return 10. Again, if I press Shift and Enter, and we define the engineering manager, his name is Peter. He is working here for 9 years. And if I press that, I can see team member number. And if I press Shift and Enter, it will return as 10. I define another class, and we define programmers. The class name is programmers. It just inherit from the employee to all attributes and methods. And here I define another method called programming language expertise, and we have self. Along with self, we want the, for example, the human resource, when they sign the contract with this employee, with these programmers, we want them to enter the language that this programmer is expert in it, and we just want to return this language like that. Very simple. Okay, I press Shift and Enter. Here we added an engineer, our engineering manager, and now that we define the programmer class, I want to say programmer 1 is equal to programmer class. His name is John, and he's 25. Again, the entrance year is 2020. Shift and Enter. Now the programmer is added. Normally, for the programmers, we should define his language expertise too. But again, If I press just shift, press enter the programmer one and experience with 2024, he is working for us for 4 years, and a programmer that programming language, for example, here it is C++, it will return as C++ itself. This is how the inheritance in object-oriented programming in Python works. I hope you enjoyed this video. Please do not forget to hit the like button if you like this video. By doing so, you will help us to be introduced to those who are interested in these topics too. I wish you a good day. Have a good day. Goodbye.